Advancing energy technologies with ultra-long carbon nanotubes. Carbon nanotubes are a unique family of molecules that look like tiny carbon tunnels with honeycomb walls. They are typically around 1 nanometre in diameter and several nanometres long. In principle, carbon nanotubes are much more efficient at conducting electricity than metals, especially since they are so lightweight and have high temperature stability compared to metals. So far, however, their full potential has been limited by the techniques used to manufacture them. Dr. Alvin Orbach-White, founder of TrimTabs, aims to overcome these challenges with the help of ultra-long carbon nanotubes, grown to lengths of over 1 centimetre or 10 million nanometres. This extreme length would allow the nanotubes to pack immense electrical currents into long-distance wires. Through their previous research, Dr. Orbach-White and his colleagues at the Energy Safety Research Institute, based on the campus of Swansea University, have gained much experience in growing carbon nanotubes from a wide range of carbon-based waste materials, including black plastics, polystyrene, and even discarded face masks. In their latest study, the researchers started by dissolving metal catalysts into water so that they could be controllably dispersed on a silica substrate. With the right balance of hydrogen and methane, and at temperatures of 950 degrees Celsius, carbon atoms streamed through the catalysts to form ultra-long carbon nanotubes. Dr. Orbach-White's team performed this experiment with multiple chloride catalysts, some containing 2 metals compared to a control containing only iron. They then used a combination of advanced imaging techniques to determine the lengths of the carbon nanotubes that had grown from each catalyst. They discovered that the iron chloride catalyst performed better than all the others. In this experiment, the carbon nanotubes grew to a whopping 1.32 centimetres in length. On the other catalysts, the nanotubes reached no longer than 1 centimetre. These results reveal important insights into the conditions and chemical reactions necessary to grow carbon nanotubes to their longest possible lengths, and will inform future manufacturing techniques. The researchers plan to improve current techniques for producing ultra-long carbon nanotubes at industrial scales to be used as the next generation electrification material. If achieved, ultra-long carbon nanotubes could pave the way for the widespread use of nanotubes across a diverse array of useful applications, including faster electronics in computers and smartphones, longer distance power transmission in renewable energy systems, higher capacity batteries and supercapacitors, transparent and conductive films, and possibly even superconductors, all of which could become crucial components of next-generation global grid technology.